Hey, this is Mr. Hansen. I wanted to talk with you about composition of functions today. And the main idea of this is you're just putting one function into another function. That's the big idea. Let me see if I can show you with an example. Let's say that you want to purchase a sombrero and you're in Mexico and you're kind of curious. You need to figure out how many dollars this sombrero costs, but the sombrero is for sale in pesos. So that's kind of the idea here. So I'm going to set up one function. This first function is f of x equals 100x. And x, my input is dollars here, and my output is pesos here. So if I had $1, it'd be worth 100 pesos. $2, 200 pesos, and so on. Okay, my next function is g of x equals x over 3,000. And so x stands for number of pesos. Interesting, here my input is pesos and here my output is pesos. That's going to be important in a minute. So x is number of pesos. And if I had 3,000 pesos, 3,000 divided by 3,000 would give me one sombrero. If I had 6,000 pesos, 6,000 divided by 3,000 would give me two sombreros, and so on. Okay, so now I have the function g, but instead of putting x in for the input, I'm putting f of x in for the input. So the output for the first function, which gave me pesos. So you might remember f of x was 100x. So I'm just going to take that and put it right there. And it gives me this function here. So 100 times, and remember this x in the original was dollars. So now we're going to put dollars in here, times it by 100, that gives us our pesos. Then divide by 3,000, and that will give us our number of sombreros. So let's say we have a $30. Well, put in 30 times it by 100, we get 3,000. So input, let's do this like this, g of f of x. Oh, and I'm not going to put x. I'm going to put 30. So I'm evaluating this function when x is 30. So I put in $30 times 100 to get me the number of pesos, divided by 3,000 to get me the number of sombreros, and I end up with one sombrero at $30. Okay, if I wanted to put in, oh, and I'm going to rewrite this a little differently because there's two different notations that mean the same thing. It sounds like goff, or it looks like that, but the idea is f is inside of g. So g composite f. And this time I'm going to put in, let's put in 60 for x. So 60, and we've got 60 times 100 divided by 3,000 will give me two sombreros. So the idea is I'm just putting one function inside of another. Basically, I'm going from dollar. Let's make a little function machine here. So I'm taking dollars and I'm timesing by 100 to get pesos. And then the output for the pesos becomes the input here. And I'm dividing by 3,000, and I get out the number of sombreros there. So take our money, times it by 100, that turns it into pesos. Now we take our pesos, divide it by 3,000, that turns it into sombreros. And rather than using two functions, we just kind of put one function right inside the other, kind of like this. And then both steps are happening there. We're taking the output here, and this is x divided by 3,000. We're just putting it right there where x is. It becomes the input, and And that's how that works. So hopefully that helps a little bit. Let's talk a little bit more about two other things with composition of functions. First of all, determining the domain and range for, let's say we've got g of f of x, meaning we're putting f inside of g. So let's just kind of follow the path here and see what happens. If I have 1 for f, I put it into the first function machine f, and I end up out with 6. And then I put 6 in, and I end up with 8. So 1, 8 is a possible ordered pair here. If I have 3, I go to 2, and then from 2, I go to 7. So 2, 7 is a possibility. I'm sorry, we started that with 3, 7. If I have 4, I go to 7, but can you see a problem here? 7's not being accepted for this new function g, so it kind of stops right there. So we aren't going to be able to use 4 because it's not going to give us an output, and we won't have any output for it. Okay, I have 5, I go to 9, and again we have kind of the same problem. So I'm going 5 to 9, and then 9 does not have a place to go from there. And so the domain for this particular function would be 1 and 3. 1 and 3, that's it. And the range would be 8 and 7. Something like that. So hopefully that helps you kind of understand how domain and range works. You can kind of just see if your inputs follow all the way through and give you an output. If they don't, then you kind of have to eliminate them. All right, one last thing. Earlier we learned a little bit about inverse functions, and one way to tell if two functions are inverses is if you use composition of functions both ways and you get an answer of x, it means they undo each other perfectly and they're inverses. So let's try this one. I've got, I'm going to start with this right here. So this is saying we're putting g inside of f. So I'm going to take 3 cube root of, and in place of x here, we're going to put x cubed minus 4 like that. So that's kind of that function there. Let's go ahead and figure that out. So I'm just going to call this y for a second. And I'm going to switch the place of x and y. That's what you do with the inverse functions. Hold on just a second. I just have to determining if two functions are inverses. I just have to see what I get when I put one inside the other. I'm sorry. Let's try this again. So we're going to take cube root of x cubed minus 4 plus 4. So we're taking g right here, and we're just kind of putting it in right there. So let's see what happens with this. Well, we can simplify the minus 4 and the plus 4. They cancel out. And we get the cube root of x cubed, which is just x. Now we take the other function. So this is the function g. We're putting f inside of that. So the function g is x cubed minus 4. And in place of x cubed, we put that whole thing right there, right where x is. So cube root of x plus 4 cubed minus 4. And the cube and the cube root undo each other, so we get x plus 4 minus 4. And then these are inverse properties too, and so you get just x again. And so you know with a lot of confidence that these two functions are definitely inverses. All right, thanks for listening. I hope this helped you understand composition of functions a little bit better. Just remember, it's putting one function inside of another. This is Mr. Hansen signing out. Have a good day.